Good morning. Today I'm going to do a super quick video, or relatively quick video, sort of like that Dirac while, large numbers thing, only re-quantum flux because they're almost like the same in a way. Okay, so the quantum energy, which is sort of like what exists even when there's nothing. Like what is there underneath everything is sort of this idea, right? Now, neutron decay cosmology basically posits that the whole universe is a little spinning ball of light, essentially, okay, trapped over its own gravity. A ginormous-ish black hole, infinitely large, even though it's in a closed space, but there's infinite points on any surface, so anyways. Okay, and then we are the membrane, and the membrane is sort of like photons. Okay, photons going this way, trapped in a two-dimensional plane of time. It's actually 3 dimensions, but we're treating it as 2 dimensions or 1 dimension in this picture. But the idea is, like an event horizon, photons get trapped on the surface of an event horizon. Okay, you end up in orbit. So all these photons are going in orbit. So this is, I just in another thing, this is going this way. These are photons. This creates a low pressure, Bernoulli's principle, which is gravity. So this layer, this layer is the quantum field underlying everything. Okay? Photons trapped 90 degrees to us so that we don't interact with them. But the quantum flux, there's 2 versions of the quantum flux. One is the classical, which is generally called lambda. And then there's the quantum mechanical version, which derives a very, very different value. In fact, because the classical version, lambda, is very, very, very small. I can't remember the number. The number's really not that important, except that I'm pretty sure that lambda, when you look it up, this is how much curvature you need before a neutron will spontaneously manifest, or like the curvature will demand that a neutron crosses. There, that's that value. This value, which was astronomical, it's 120 orders of magnitude or something ridiculous larger than this one. Okay, the quantum mechanical one, that's because this measures sort of the ripple. At what inflection point do we need to replace matter? This one is the total sum of what is going on underneath here, which is why it's so astronomically large. Because basically, underneath the entire universe in the neutron decay cosmology model, there's a layer of pure energy, solid energy, endless Planck sphere-sized units of space, though they don't exist yet. I think that's just the minimal inflection you can give to the fluid that is space is 1 Planck length. Like that's the curve. That's the minimum curve you can possibly give it. It's the nature of space. Okay, but we have this layer that's neutrons, photons, zipping around. Basically like a layer of maximal noise underneath. That's this. When you create a wire and you run some electricity through it, you're shooting the energy across the surface of the photons. You're creating this pressure, this flow on the surface of all the electrons in the metal, because they're all sort of touching each other and like to share. So it just goes shooting across. Bernoulli's principle, low pressure, only because this is only electricity and not photons. This creates an electrical field and magnetic field. 90 degrees with a chirality because we're on one side. And if you're a spinning ball like this, when you look at it from this side, it's going counterclockwise. But if you were looking at it from this way, oh, it's going clockwise. This is why chiralities too. So yes, the two quantum fluxes and why they are so vastly different. One is measuring the ripple, sort of this. This is the amount of curvature needed to manifest. This is the total sum of what the heck is going on underneath here, which is why it's such a large value, but I don't think we can tap into it that easily because you have to work at it to tap into it. You know, the universe wants to be flat, so whenever you're perturbating it and making it move over the way you want, there's now a force trying to get it back up because it wants to be chill. You know, this is why you have to put energy in to make that electricity flow. Only gravity goes by itself. And then the natural occurrences of gravity, galaxies, plasma filaments, all of this stuff, that flows path of least action without making any effort because gravity is. But when you want it to happen in a circuit, then you got to give it a little boost because now we're going against the flow of nature and we're trying to make it do what we want, and therefore you have to force it, such as nature. So this is why the classical value is so small, because it's only the minimum perturbations to manifest a neutron in the curvature. And this one is so large because it's everything that's happening underneath everything. I know, it sounds totally loony. Consider it so if you want. But I think this is a very good model for how to approach our universe. Anyways, have a good day.